And within each neuron, which is a primary cell located in the brain, there are serotonin and serotonin receptors. So you can see, stays a point here. Oh, it kind of works. You can see that these small dots right here are the serotonin molecule, and then this kind of square with a triangle dug out is a depiction of a receptor. So a receptor is just a protein located on the outside of the cell, and a small molecule binds to it, and once it binds, it elicits a chemical response within that cell. So the small molecule is specific for each receptor, and so there are specific serotonin receptors out there. And you can think of it as like a lock and key type analogy. So if a molecule, if you have a key that fits in the lock very well, you're going to be able to open the door. If you have a key that doesn't fit, the door stays closed. And so if the molecule fits into the receptor just right, it elicits a chemical response. So that's the analogy to think of. So where does serotonin come from? Well, if you ate too much turkey for Thanksgiving, you probably made a lot of serotonin, because tryptophan is present in turkey, and tryptophan is converted to serotonin in the body. So serotonin, since it is a neurotransmitter, it regulates a lot of things. It regulates your mood, hunger, learning, sleep cycles, cognition, what you perceive to be real or not. And there are 7 receptors in the body that bind serotonin, denoted 5-HT1 through 7. And so the 5-HT stands for 5-hydroxytryptamine, and there are 7 different proteins that serotonin can bind to elicit different chemical responses. So the receptor that I was interested in and that my research advisor wanted me to focus on was the 5-HT2 receptor. And so this receptor is in charge for regulating your mood, cognition, memory, learning, and anxiety. And so there are lots of pharmaceuticals on the market today that target the 5-HT2 receptor. One of them is Sansert, which prevents migraines, and that's the structure of it shown here. Another one is Prozac, which is an antidepressant. And lastly, psychoactive drugs such as LSD, mescaline, and psilocin also bind to the 5-HT2 receptor. And so I've highlighted in blue the structural characteristics that are similar to these pharmaceuticals and to serotonin up in the upper right-hand corner. And so it's not a surprise that these molecules bind to the serotonin receptors in a similar way, since they do possess structural features that are similar. In addition, I'd like to point out how awesome organic chemistry can be, in that you can take a hallucinogenic drug like LSD. By doing a few different chemical transformations, you can see that we added on a methyl group from here to here by changing the group on nitrogen. You can take something that is a hallucinogenic drug and make it a very potent anti-migraine medicine that doesn't have any sort of psychoactive properties whatsoever. longer alkyl chain right there. And so it was fun, it was exciting. I didn't really know what I was doing my first few times, but your advisor is there to help you throughout the way. And basically this sequence was fairly straightforward. It had all been done before. And from this molecule, 3 steps later, I got to another one. And then by treating this with strong base, I was able to make my key intermediate, which then diverged to make 2 of my the 2 desired molecules that I wanted. But I actually didn't finish. Oh, these are pictures of me on the left. And so here I'm adding molecular bromine to a flask. Molecular bromine is this very vibrant, bloody red color. It's a halogen. It's pretty nasty. I got some on my arm. I have a scar from it. Here's the flask. Here's the reaction that I have under ice. And so this reaction releases heat as it goes. So you have to keep it cold to keep the reaction under control. You can see that I have a line going into it. And so that line is a nitrogen line. So this reaction cannot be under air. And so you keep it under nitrogen, which is an inert gas. And then lastly, this reaction on the far right is I take a 30-gram scale alkylation. This was the first reaction I ever did. And it was so ridiculous because this glassware is huge and I don't do stuff anything like this nowadays. And there was so much chunky solid stuff in it that I had to use a mechanical stir just to stir it up. So a simple stir bar wouldn't even